second part of operations on complex numbers. Now we're going to talk about division. And division is a little bit more complex. We'll start with, I seem to like 7s and 3s today. All right, so there's our question. Now we've got division. The key with division is we can't leave an I, that says leave, I in the denominator. So it's kind of like a radical, and I'll point you off to some other resources to remind you that this is the same thing that we would do with radicals. Well, how do I get an I out of the denominator? If I were to label this problem type, I would say this type, the denominator is only imaginary. Wow, can't spell today. Imaginary. Okay, so the denominator is only imaginary in this type. So we are fine with the 4. We have no problem whatsoever with the 4 in the denominator. What we have a problem with is the I in the denominator. So the I is the only thing we have to get rid of. You've got to think about, how do you get rid of an I in the denominator, or an I in general? Well, we know we can get rid of an I when we times it by another I. So just timesing it by I will get rid of the denominator. If you forgot that and you times it by 4i, you'd be fine. You just have to do more simplifying later. I often forget that and I end up having to simplify, but that's okay because I'm pretty good at math. Sometimes just not good at remembering stuff. So 4i squared on the bottom, that's okay because we know what I squared gets replaced with. Now we have 7i plus 3i squared. Don't think you can cancel those I squareds. Remember that 4i squared belongs to both of those guys. Sure, you could cancel it on the right, but let's do this in a methodical way instead. Let's not get ahead of ourselves. So we have 7i over here plus 3 times -1, and then we also have 4 times -1 because we never want to leave an I squared around. We have 7i plus 3, no, minus 3 over -4. So now I'm going to split that into its real part and its imaginary part. 7i over -4 and -3 over -4. Well, -3 over -4 is just 3/4. There's my real part. And then I've got a negative here. So I'm going to use that as a minus. 7/4, and I like to put the I off to the side. Right, so that's standard form because we have real and imaginary. Notice the I goes off to the side. So when we have those, there'll often be fractions, we put the I off to the side. It's no different than the I being in the numerator. It couldn't be in the denominator. It's no different than the I being in the numerator, but really it's just 7/4 is the coefficient. Just like in, when we got started, 4 was the coefficient of I. Now 7/4 is the coefficient of I. So that's our answer. 6i divided by 5 plus 2i. So this time the denominator has a complex number. All right, so we have to ask ourselves, how are we going to get the I out of the denominator? Well, if we just times it by I, that would get rid of it here, but we would introduce it there. So that's not going to work. What we have to multiply it by is called the complex conjugate. Okay? Multiply, just like before, we have to multiply the top and the bottom, but we're only multiplying the top because we have to, get the denominator not to have an I. We're going to multiply it by the complex conjugate. And I'll put a link to some, more elementary things on conjugates and with square roots and stuff. But this time our conjugate is going to be complex, meaning a complex conjugate is the same real part with the complex, not complex, with the imaginary part having the opposite sign from what it started with. Not the opposite sign of the real part, but the opposite sign of the original. So, meaning on this one, here's my original, 5 plus 2i. So the complex conjugate is going to be 5 minus 2i. Fancy name, easy thing to do, right? Just change it to a negative 2i. Okay, so what we're going to do is we're going to multiply the top and bottom by 5 minus 2i. So we've got 6i times 5 minus 2i, and then we've got 5 plus 2i times 5 minus 2i. Okay, so I just multiplied the top and bottom by the same thing, so that's just multiplying by 1, that's always allowed. And so on the top I just have to distribute. 6i times 5 is 30i, 6i times negative 2i is negative 12i squared, and hopefully you see that that'll end up, that I squared will turn it into a real number in just a minute. I'm going to do the work for the other part off to the side, because when we do this, I'm going to do it with the box. I might not show it every time, because when you see what happens, you'll see why it works, and you'll see why you don't want to do the box every time. So I'm going to times it by its complex conjugate. This is 25. This is 10i. Oh, look, this is negative 10i. And then negative 4i squared. So every time you multiply by the complex conjugate, these guys cancel each other out. And that will happen every time. So, do you have to do the box every time? If you want to, go ahead. If you see what I mean, it's just going to take up a lot of space. You're just going to square the first thing, square the last thing. It's just like the difference of squares when we're talking about regular binomials. Every time you multiply by the complex conjugate, the i's, or those diagonal terms, cancel. So that's how it clears out the i's. And so every time this will end up being that times the negative 1. And so again, I'm just going to write down here that's going to be 4, positive 4, right? So it's going to be 25 plus 4. So I'm going to go back to my original problem now and say, all right, that's 29. And I'm also going to go back and change that to a negative 1. So it's going to be 12 over 29 plus 30 over 29i. 3 plus 4i over 2 minus 6i. So that's my original problem. I got to think about what's the complex conjugate. It's going to be 2 plus 6i. So I'm never going to need 3 minus 4i. I'm fine with i's on the top. It's the bottom that we have to get to have no i's. So I'm going to multiply 3 plus 4i times 2 plus 6i, and I'm going to multiply 2 minus 6i times 2 plus 6i. So in this case, the bottom is the easy part. The top part's going to take more work because stuff isn't going to drop out. So I'm going to do the bottom first. I know I'm going to square the 2, and I'm going to square the 6, and I'm going to square the I. Okay, I'll show you the work, but I want you to see where it's not as much work necessarily as you think. Right? What did I do? I guess I will show the box. So for the denominator, I did 2 plus 6i and 2 minus 6i, 4, negative 36i squared, plus 12i, minus 12i. These guys cancel. This is negative 1, so this is plus 36. So it's 4 plus 36. So on the bottom, I'm going to have 40. Okay, numerator, going to take some more work. The numerator, stuff's not going to cross out. So for the numerator, I've got 3 plus 4i and 2 plus 6i. So I got 6, 8i, 18i, and 24i squared. This is going to be negative 1. So I'm going to have 6 minus 24. I brought that one over, I brought that one over. 24 times negative 1, give me negative 24. Plus 8i plus 18i, so it's going to be negative 18 plus 26i. Ugly numbers, that's okay. Negative 18 plus 26i. So from this point, it's just simplifying. We're fine. We've got the I out of the denominator. Now we just have to split it up and simplify. So I've got negative 18 over 40 plus 26i over 40. And actually, let's move that I off to the side. Okay, and sometimes these will have different factors that we can simplify, but this time everything just has a 2 in it. So we could have simplified it earlier, but we're going to simplify it now. So first one gets divided by 2. Second one gets divided by 2, top and bottom. So there's my answer. Oh, I didn't divide my 26. Let's try that again. There we go. So everything got divided by 2. We pulled a 2 out. Divided 26 and 40 by 2. Divided 18 and 40 by 2. So think about how all those things we just did relate to other things we've done in the past.